This is the activity series by Hannah Bergen. First, let's talk about single replacement reactions. They happen when an element reacts with a compound to form a different compound and element. An example of this would be when zinc reacts with hydrochloric acid. As a reactant, zinc is a free element and hydrochloric acid is the compound. The products are zinc chloride and hydrogen gas. This is a single replacement reaction because zinc has replaced hydrogen in the compound and kicked hydrogen out back into its elemental form. It is important to note that hydrogen as a diatomic gas will always revert to H2. When elements and compounds mix, their reactions are varied. Sometimes no reaction occurs, and other times the reaction can be as extreme as an explosion. When sodium metal comes in contact with water, there is a violent explosion. Sodium, a group 1 alkali metal, is extremely reactive. This reaction forms sodium hydroxide, NaOH, and hydrogen gas. The sodium in NaOH is more stable as it is an ion, and is isoelectronic with a noble gas. Since sodium is more stable on the product side, the reaction will occur most definitely, and sodium will try to avoid its unstable elemental form when possible. When gold comes in contact with water, there is no reaction. This is because gold is very stable in its elemental form, as this is essential to the use of gold in jewelry. In order to determine if a metal element will react with a compound in a single replacement reaction, we look at the activity series. This is the activity series of metals, which is a list of metals ordered by their likelihood to react and is used when predicting if a single replacement reaction will happen. When you are comparing two metals, the metal on the top trumps the metal on the bottom. The metals listed on the top are the most reactive, and the metals listed on the bottom are the least reactive. You may have noticed that hydrogen, a nonmetal, is on this list of metals. Hydrogen is included for the purpose of comparison. When metals react with acids that have hydrogen, we must be able to compare hydrogen and the metal to see if a single replacement reaction will occur. Don't forget, the metal on the top trumps the metal on the bottom. Let's practice using the activity series. Example 1 says if magnesium is placed in aqueous zinc nitrate, will any reaction occur? We have magnesium, a metal, and zinc nitrate, an ionic compound. This is a single replacement reaction. Our first step is to write it out. The free metal, magnesium, will replace the metal ion zinc in the compound and kick out zinc back into its elemental form. The only way to tell if this reaction will occur is to compare the two metals on the activity series. First, we will find magnesium and then zinc. Because magnesium is above zinc, it will react to replace zinc in the compound, since top trumps bottom. For our next example, we are asked to determine if a reaction will occur when manganese is placed in aqueous sodium chloride. Manganese is a metal, and sodium chloride is an ionic compound that is commonly known as table salt. The first thing to do is write out our possible single replacement reaction, and then check out our activity series. We first find the free metal, manganese, and then we find the metal in the compound, sodium. Sodium is above manganese on the list, and since top trumps bottom, sodium will hold its place in the compound and no reaction will occur. We write this as NR, or no reaction, after the yield sign. Hopefully, you learned that the activity series is a list of metals used to predict if single replacement reactions happen. Elements on top are most reactive and will replace other metals below. Top trumps bottom. Some metals are more stable as elements and others as ions and compounds. I hope that was helpful.